So here in question 5, we want to find the integration of x times x minus 1 to the power 3, and we're using u equals to x minus 1. First thing, we just du on dx, and that x just becomes 1, the minus 1 disappears. If I switch those two, I just get dx equals to du, very simple. But that means I won't be able to cancel out the x up there, so I'm going to have to rearrange this equation. So x equals to something, and here x equals to u plus 1. Essentially just move the 1 over. And now I can substitute. So here, what I've done is this x minus 1, yeah? That was what we let u equal. So that's your u here. Whereas this x over here, yeah, because we worked out from rearranging x equals to u plus 1, that's given me that there. Can you see that? So this has become u plus 1 and this has become u cubed. All right? And finally, this dx, I can just change straight to du. So now I just expand that. So that becomes integration of u to the power of 4 plus u cubed du. And the best way to do that is just split up the integration into this over here. And now just very simple integration. That will be u to the power of 5 on 5, u to the power of 4. So just add 1 to the index, and it will be multiplied by 1 or 4 or divided by 4, whichever way you look at it. And now we just need to substitute, good, the x back in. That's all you need to do. And that's all you need to do is literally, instead of writing u, write it in terms of what we let u equal. And remember your plus c on the end. So here you can see, similar to the question before, when we substituted in the du, we were still going to be left with this extra x here. And remember, we can't do anything if there's an x there. So we think, how are we going to make that a u? By rearranging this equation and substituting it in, and that's it for that one. So here, I want to find the integration of this, and I'm going to be using u equals to x minus 4. So by now, we're quite familiar with this process. So firstly, differentiate this. X just becomes 1, the minus 4 disappears. Flip those two, so you get dx equals to du, very easy. But if I substitute in u here, you can see I'm going to be left with an x squared. So that's going to be a problem for that. I need to rearrange this, put the minus 4 over to the other side, you get x equals to u plus 4. And now I can substitute. So what I've done is, firstly, this x minus 4, yeah, I let that equal to u. So that's just my u to the power of 4 there. And then secondly, because I worked out that x equals to u plus 4, this x squared has now become u plus 4 squared. Can you see that? And then finally, dx substituted for du. Yeah, so just make sure it's all in terms of u here. And now, before we integrate that, what do we need to do? That's good. We just need to expand everything. So with this one, square the first, u squared. U times 4 is 4u, multiplied by 2, gives you 8u, and then square the last. So it's 16, multiplied by, you can see better here, u to the power of 4, okay? Multiply it all out, to the power of 6, power of 5, and to the power of 4. And as previously, the best way to work this out is just to separate the integrations into 3 separate ones like you've done here. And that plus 1 becomes power of 7, plus 1 becomes power of 6, so 8 on 6. And this becomes u to the power of 5, 16 on 5. And all we need to do now is substitute u for x minus 4 into all of them. Yeah, like that. And just simplify where you can. So you can see here 8 and 6 can be simplified to 4 and 3. Make sure there's nothing else more you can simplify. Always add your plus c, and that's all you need to do. Okay. So what you've learned from this method is just an extension of your basic substitution when you can't get rid of all the x's. And it's easy to remember because you need all u's here if you want to differentiate in terms of u. Yeah, and that's it for that module.